For our project, we chose our device to be a stapler because it has 4 different materials and 6 different manufacturing processes. Some of the performance requirements for a stapler are that it must provide enough force to penetrate paper, it must bend the metal in order to secure the stapler to the paper, it must be easy to operate, it must be safe and ergonomic, it must hold the paper in position while stapling, it must be able to replace staples easily and hold a lot of staples. It must move each stapler into the loading position after one staple is used. And it must have enough force in order to penetrate multiple pieces of paper.
The most common materials that are used for the production of the different parts of the stapler are aluminum, steel, and plastic. The materials were selected based on different DFMA analysis. Different materials were tested for each of the parts. For example, based on a strongest plate test run on the anvil, it was shown that steel would be the best material overall, although other materials such as aluminum and cast iron provide the minimum weight and minimum cost respectively. Due to its low weight, aluminum was used for the production of the base. Spring steel was used for the production of the spring because of its low cost and minimum weight. Alloy steel was shown to give the best performance for the staplers. The manufacturing processes that were used for the production of the stapler were molding, sheet metal working, die casting, etc. Parts that were mostly made from metals, such as the anvil, the staple guides, were manufactured using sheet metal working. Plastic parts were manufactured using molding, such as the plastic cover was produced through injection molding. Due to the shape of the spring, coiling was used for its production. Casting was also another popular method of production and used for the manufacture of the pins, the base, and the anvil actuator.
Design for manufacturing was implemented in the manufacturing of this stapler. DFM was addressed by considering multiple factors such as simplicity, the standard use of materials, standardization of design, and the use of easily processable materials. A total of 17 parts were used, and the cost for each of the parts: steel, aluminum, plastic, and rubber are the standard materials used to construct the stapler. The design of the stapler is standardized to fit normal staple sizes. The plastics are made through injection molding. The rubber grip on the base is molded, while all aluminum components are die casted or processed through sheet metal working. The steel components are either coiled or processed through sheet metal working. Other factors of DFM include avoiding secondary operations, designing for expected levels of production, utilizing special process characteristics, and minimizing the assembly. Although there are no secondary operations like shape removal, there is the tertiary operation of electrostatic painting, which is used to prevent rust and improve the aesthetic. The stapler was also designed for mass production by using cheap materials and utilizing low-cost manufacturing techniques. One of the special processes used in manufacturing is formation of coil springs. The coil springs are made by winding steel wire around rods and heat treating them in order to prevent the elasticity of the spring. Assembly is minimized by using robots for assembling pins, stampings, and springs in the upper and lower halves of the stapler. The only assembly operations include attaching the plastic caps and the rubber pad to the stapler.
There are several principles of design for assembly that we will address with respect to the design of the stapler. Firstly, minimizing the number of parts. There aren't many parts in this design, but there are several adjacent parts of similar materials that could be combined. Secondly, another element of design for assembly is minimizing the number of fasteners. This design utilizes press fits for the pivot pin, welding to attach the end cap to the upper arm, and a snap-on plastic nameplate. All of these attachment mechanisms minimize the use of fasteners. With regards to the actual actions of assembly, the design of the stapler minimizes the number of assembly planes. Once the initial parts have been assembled via machine, the final assembly requires only one access. and can be assembled in the z-axis. The design also ensures visibility of all critical components. The spring, upper leaf spring, and lower staple slide are all easily visible and vital for optimal performance of the stapler. The parts utilized in the assembly of the stapler are also self-locating and aligning. The top cover automatically holds the other components of the stapler in the proper location during assembly. Finally, part tangling is minimized. For example, the spring has closed ends to prevent hooking other springs during storage.